Hello everyone, myself Rajashri Dhonnar, Assistant Professor, Shivaji Rao S. Zondre College of Pharmacy, and today I am going to deliver a presentation on topic to determine the surface tension of given liquid using stalagmometer. So these are the key points of my presentation. And aim of our today's topic is to determine the surface tension of given liquid using stalagmometer. So we have to determine a surface tension. So before going into the practical work, we have to understand what is surface tension. So in first point we can see that surface tension is the one of the property of liquid. This property of liquid arises from intermolecular forces of attraction. A molecule in the interior of a liquid is attracted equally in all directions by the molecules around it and net force is zero. But a liquid molecule present on the surface is attracted a net inward force called as surface tension. So in given diagram, in beaker we can see two molecules. One molecule present interiorly and another molecule is present on surface. In interior molecule pulled equally in all direction, but the molecule which present on a surface is pulled inward only. Due to this, it produces a surface tension. And surface tension is a property of liquid only, and the property of liquid is due to the intermolecular forces of attraction. The liquid surface is therefore under tension and tends to contract to the smallest possible area in order to have the minimum number of molecules at the surface. It is for this reason that in air, drops of liquid assume spherical shapes because for a given volume a spherical has minimum surface area. The surface tension is defined as force in dynes acting along the surface of liquid at right angle to any line 1 cm in length. This is the definition of surface tension, and unit of surface tension is dynes per centimeter for CGS unit and Newton per meter for SI unit. So all concepts are clear in this slide regarding surface tension. Let's move on to the practical part. So before going to the practical part, we have to know about a stalagmometer. So what is stalagmometer? Stalagmometer is shows in a diagram. A surface tension gives a definite shape to drop of liquid. More is the surface tension, larger is the drop size. This principle is used in a stalagmometer. So surface tension and drop size is directly proportional. Stalagmometer is an apparatus with a bulb and capillary. The capillary tube which we have seen in diagram of stalagmometer. The liquid is filled in the bulb and allowed to flow through capillary in the form of drops. If the surface tension is high, larger drop is produced and number of drops are less for given volume. Thus, more is the number of drops, less is the surface tension. See in the diagram of stalagmometer, there is a bulb which is round shape and there is a capillary tube which is under the bulb. So in bulb there is a liquid which pass through a capillary tube and then it falls in a beaker dropwise. So in third point we can see that the higher surface tension, larger the drop. If drop is larger, then number of drop is less. So the number of drop is more, we can clearly say that less surface tension of that liquid. Apparatus required, that is beaker, stalagmometer, stopwatch and density bottle. And formula for surface tension is gamma 2 divided by gamma 1 is equal to N1 divided by N2 multiplied by D2 divided by D1. In this formula, gamma 2 and gamma 1 are the surface tension of our liquid and water. N1 and N2 are the drops of water and our given liquid, that is ethanol, and D2 and D1 are the densities of water and that given liquid. So according to the formula, we have to first determine D1 and D2 values. That means densities of water and liquid. So first part of our experiment is determination of densities of water and given liquid, that is ethanol. First step of our procedure, clean the density bottle with chromic acid solution and then with distilled water, rinsed with water and ether and then dry. So we use chromic acid for cleaning. Chromic acid is a powerful oxidizing agent, and also we rinse with water and ether. Water and ether are also act as a cleansing agent. Ether is an organic solvent which also used in a industry for cleansing purpose. The next point is wet and empty density bottle, that is W1. The next is fill the density bottle with distilled water completely. Insert the stopper and wait again. After that, take out distilled water and rinse the density bottle 2 to 3 times with given experimental liquid, that is ethanol. Fill the given experimental liquid into density bottle and record. So this is our W3. So what is W1? The weight of empty bottle. What is W2? The weight of density bottle with water. And what is W3? The weight of density bottle with ethanol. So this is our part 1. What is part 2? The determination of surface tension. This is the actual step where we have to use a stalagmometer. So let's see the procedure one by one. First point, clean the stalagmometer with chromic acid solution and then distilled water, rinsed with water and ether and then dry. Attach the stalagmometer to the burette stand in exactly vertical position. Hold a beaker containing distilled water and dip the lower end of stalagmometer in it. Suck the distilled water just above the mark A. Allow the water to flow freely. Adjust the flow rate using pinch screw clip so that it should deliver 15 to 20 drops per minute, 3 to 4 drops in 15 seconds. Count the number of drops falling between marks A and B. Repeat the recording of number of drops 3 times for distilled water as well as for given experimental liquid, that is ethanol. So in diagram we can see that there is a point A and there is a point B. So we have to suck a liquid by using rubber bulb up to the point A, and then we have to pass that liquid through the capillary tube up to each reaches to point B, and we have to count the number of drops which are dropped in beaker from traveling of liquid from point A to point B. So this same procedure we have to continue for ethanol also and for water also. Then observations and calculation. Then first is room temperature. Room temperature, it means the temperature at which you perform a experiment. Then weight of empty density bottle. We have found W1, W2 and W3 in part 1 of our experiment. So write that values in these 3 points. Then last is volume of density bottle. It may be 50 ml or it may be 25 or 100 ml also. Then these are the formulas of density, that is D1 and D2. In D1, W2 minus W1 divided by volume of density bottle. So we have to put volume, that is W2. W2 means density bottle with water, minus W1, that is minus weight of our empty bottle, then divide by volume of our density bottle. Same process for D2, but we have to consider here W3, that is density bottle weight with ethanol. Then we have find D1 and D2, put that D1 and D2 values in our surface tension formula. In this observation and calculation part, you can see a chart. Chart contains the drops for water. We have to take 3 readings for drop count. So 1, 2 and 3, we have to put that value, then count it a mean for that. Then for same procedure for ethanol, then count mean for that. Then we have all values D1 and D2, that means density of water and ethanol, N1 and N2, that means number of drops for water and ethanol. From all these values we can easily find out the surface tension of our unknown liquid, that is given liquid, which is ethanol, using stalagmometer, and according to that we can interpret the result. Thank you students. Hope this presentation will help you.